Well, this week is a holiday here in the US, and in addition to that, I had jury duty, which basically means I had zero free time to make videos and no time to do experiments. But I didn't want to leave you with nothing, so I thought I would go ahead and do a video here for the newbies. I know once you get deep into something, it's tough to go back to the bare bones and look through the eyes of somebody who's just seeing it for the first time. And one of the sources of confusions, especially with people who don't have any technical background at all, is about simple things that we take for granted, like jumpers. And I'm not talking just jumper settings, I'm talking about what even are jumpers and what do they do. So this video flow will be a little bit more narrative, as in one part will build on the other, but I will still put time links in the video description below so you can skip around a little bit. But I do encourage you, particularly if you're new to this, to watch it from beginning to end so that you don't miss something there. So here we go, the basics of jumpers with respect to 3D printer drivers. Now, if you've ever popped one of these open, accidentally or on purpose, you know that there's just a little piece of metal in there. And essentially all that piece of metal does is jump one pin to another pin by shorting them together. And those pins are exposed on our control boards in order to let us change various settings. Now, the same thing can be accomplished with switches or buttons or just in software, but experimenters tend to like to have as many options exposed to them as possible, and just breaking out those functions on a pin and using jumpers also allows them to use those other methods with other means if they so choose. And the options that we're mostly going to be talking about here are called either the jumpers or the MS1 through MS3 jumpers or the microstepping jumpers, specifically as it pertains to the ramps motherboard. Now that's just so that we have a baseline, and because it's open source and all the diagrams are available and everybody's familiar with it. I'm also going to be using the Stepstick format, basically for all the same reasons, and I'm also going to be touching later on in the video on silent Stepstick format, which was introduced by Vatrat using Trinamic drivers, because that's where a lot of confusion has come in, since the jumper settings are so radically different than the regular Stepstick format that we're used to. Now, technically Stepsticks are not these Pololu driver stepper boards that I showed a picture of, but that's kind of the name that encompasses the entire genre of these modular boards, as developed and popularized by Pololu, the popular robotics site. Don't forget, that's what the P in ramp stands for. But the family now includes many different types of drivers, and we all just kind of colloquially call them Stepsticks. Stepstick is basically just a standardized format of what's called a breakout board, and what we're breaking out is the pins from this driver, because our actual drivers just have these teensy weensy little surface mount pins, and we're essentially just breaking them out through traces on the PCB to either set them up electrically or control their functions, or make them available to the user and then attach them to pins so that you can socket them onto your motherboard. And the confusion comes in the fact that different drivers have different functions that can be broken out to these pins. But in order for it to work in the Stepstick format, there are a couple things that have to be similar from one driver to another, regardless of what is actually on the breakout board. So most of the functions on the right side of the driver here, as in the high voltage to the motor, the ground, all the actual connections from the Stepstick to the motor itself, and then the logic voltage and the other ground, that's all going to be basically similar from one board to another. There are a couple functions on the left side as well that pretty much have to be standardized, as in the enable on the top, the position of these jumper pins, as well as the step and direct functions. So typically it's just the MS1, MS2, and MS3 pins that are broken out to jumpers on our control boards that basically let us control the microstepping, but sometimes other functions as well, particularly in the case of Trinamic drivers, but also with other chips. And then there are a few other pins like the sleep and the reset that may have different functions depending on what drivers you're using. So now that we've established which pins we're talking about, how do we even control that? Well, let's say this big black square on the left represents the actual driver IC that's nested on our little Stepstick breakout board, and the blue arrow represents the trace that connects one of the pins on that IC to a physical pin on our Stepstick. And then that pin is available on our motherboard as one half of the 2-pin header that we could put a jumper across if we want to set a particular function. And then the dot on the right side represents the other half of that 2-pin header. So to visualize that on a ramp board, here's our header, here's the one pin, here's the other pin. So to set a particular function on our IC driver, we have to send it a signal that it's going to be expecting. So with drivers like the Pololu, the IC is expecting to see either a logical high or a logical low, as in you're going to pull that either up to a logic voltage or down to ground using a jumper across those pins. So these three vertical dots on the right don't represent three different physical pins, although they could, but they actually represent three different possible states that you can send as a signal to your IC to tell it what mode you want it to operate in. So if you are sending it a logic high, you are said to be pulling up that pin to the logic voltage, or if you're sending it a logical low, that means you're pulling down the pin toward the ground voltage. Now you're not pulling it completely up to your logic voltage necessarily, or completely down to ground, you just have to pull it up or down past a threshold. And there are various states in the middle, but the typical third state, if you have a third state, is called floating, which means you're not sending it any voltage signal at all. In which case, that's called a tri-state capable pin. So let's say the jumper pin on our motherboard has the ability to pull the IC's pin up to a logic voltage. When we add a jumper across those two pins, essentially you're extending the trace from your IC across that jumper, and then you're going to be sending a signal into your IC that, hey, we have pulled this up to our logic voltage and we want to do a particular function. Same thing applies if our board provides a logical low voltage. You're going to be pulling down that pin toward ground. And if you have a tri-state pin, it pretty much just means that you're leaving the jumper off the board and not sending it any particular voltage signal at all, which is a feature we often see in the Trinamic drivers, but we don't often see in like the Allegro and Texas Instruments style drivers. Those will typically only take a logical high or a logical low, as in pulling the pin up toward your logic voltage or down toward your ground. So let's talk about our Trinamic drivers really quickly. I will use as an example the TMC 2100, i.e. the original silent Stepstick, because that was meant for purely standalone mode as opposed to smart mode, which we'll touch on briefly in a little bit. But since it was just meant for standalone or legacy mode, whichever you want to say, it does have a lot more options as far as configurations broken out to the user. And what additionally confuses, especially newbies, is that not only do you have the microsteps that are available as configurable by your jumpers, but you also have whether or not those steps are interpolated using a lookup table to an even finer division, or whether or not you use the silent mode, i.e. stealth chop, or spread cycle. Now, which combinations of these particular features you're going to be able to access is completely dependent on the designer of the motherboard that you're putting them in. And this is where things can go off the rails a little bit, particularly on boards that are either not well documented or are not open source. And that's why people, particularly tinkerers and folks that are trying to experiment, get really dogmatic about opening the source. And there are certain cases where if you don't know that and make an incorrect assumption, you can either blow up your board, blow up your IC, or blow up your step sticks. So let's go back to this diagram where, again, the square on the left is going to be our IC, and then this is going to represent the board trace going across to one part of our jumper header, and then the other part of the jumper header is connected to either the positive voltage or the ground. Now, obviously, it has to be one or the other unless you have some other kind of setting that lets you toggle between whether it's pulling it up or pulling it down. So like I said at the beginning, we're going to be using the ramps board as an example because these files are easily available to everybody. This particular schematic is posted on the reprep.org site, so you can grab it for yourself if you want. And don't worry if you don't know how to read schematics, it's fairly simple and I'll walk you through it. And the section we're particularly interested in is the stepper driver section, which is just a copy-paste 5 times of the exact same circuit, X, Y, Z, and then 2 extruders. This big rectangle represents our Stepstick itself, and then MS1 through 3 are the jumper settings, and then this rectangle right here represents the headers that we put our jumpers across. So we can take this and go back to the diagram and see what states we can possibly put these various jumpers in. So if we first look at jumper number 1, we see that there's this 100K resistor that if we don't have any jumper put on it, it will pull that pin down toward the ground voltage. But if we put a jumper on there, we're bridging between number 1 and number 2 pins, which means we're pulling that up to our logic voltage, which is designated as VCC, usually 5 volts in the case of 8-bit or 3.3 in the case of most 32-bit. So at least in the case of our MS1 pin, we have a default state with no jumper that pulls it down for a logic low, or if we put the jumper across as designated by this dotted line, it pulls it up to our logic voltage, or VCC as designated on the schematic. And here's where another little additional area of confusion comes in, depending on which step sticks you're using. Because in the case of the ramps board, we have an automatic pull down or pull up for MS1, and then for MS2 and MS3, those are floating unless you put a jumper across, then they are pulled up. But for our purposes here, when we get into the silent step stick options, we'll essentially just consider it pull up, pull down, or float. Or you could say plus, minus, or 0. So getting back very quickly to our ramps and our standard step stick format, it seems like the options that we have, because of what we saw in the schematic diagram, are MS1 can either be ground or VCC, MS2 can either float or VCC, and then MS3 can either float or VCC. But that's actually not true. If we look at the logic table on the Allegro datasheets and cross out all of the options that we would not have available, that means the only setting we would be able to accomplish is 1/16 microstepping, and obviously we know we can put it in more modes than that. Because even though our ramps board only provides pull downs for one pin, i.e. the first jumper, all the pins' natural state is actually pulled down. Because inside the IC itself, there are pull down resistors on each of those pins. Because this is not a tri-state IC, and they didn't want those pins to accidentally be set into floating mode, because that would have made the circuit, well, unpredictable under certain use cases. And that's fairly obvious when we see that that truth table we drew up is completely wrong, and we do actually have access to many more stepping modes. Now, wait a minute. If we have internal pull-down resistors, what's up with the 100K pull-down resistance on the ramps board? Well, at first that would seem like a strange apocryphal detail of the design of this board, but in actuality it's just a vestigial feature of a previous design. Using the A4983 IC as opposed to the A4988 that we typically use, that's long since been discontinued, and that did not have a pull-down on the MS1 pin. The community never really iterated past ramps version 1.4, so that feature just kind of stayed in the quasi-final level, and then any clones or any companies that picked up on the board and continued to carry on in that tradition just sort of left it the way that it is, not fully understanding what the purpose of that resistor may be. But remember, this only applies to the ramps board, and this only applies to the Pololu drivers with the Allegro chips on them. So even for some boards that may have been based off of the ramps board, it's very possible that they added additional resistance for pull down or pull up because that value wasn't sufficient to fully pull down or pull up the chip as required by the particular driver on that subcarrier board. Which again is why a lot of the community, particularly the hardcore tinkers and experimenters, demand open source, because it could be any number of crazy combinations of pull-ups and pull-downs, and those pull-ups or pull-downs may or may not be on the subcarrier boards, i.e. the step sticks as well, so it's nice to have the source for that too. Because we're way past the era of just having to concern ourselves with the Allegro drivers, not the least of which being Trinamic. Yes, we've gotten to the Trinamic section. But by Trinamic, I basically mean the silent step stick format that was pioneered by Vatarat using Trinamic ICs on the silent step stick breakout boards, which can get fairly complicated from family to family as they have different pinouts and different options available to them, including the option to run them in either standalone or legacy mode like a Pololu driver, or in smart mode over either, serial UART or SPI connection, which can potentially just render all of the jumper settings moot because any of the configuration options that are available you can control either through your firmware or live via G-code. So to explain why this gets complex, let's use these two simple diagrams that I drew up in GIMP to represent our two different classes of boards. On the left are our legacy boards, the standalone boards like the Pololu drivers, and on the right are our silent Stepstick Trinamic style drivers. And if I add the pin designations onto here, you can see the areas of similarity and the areas of differences. Pretty much like I said in the beginning of this video, any of these headers on the left basically have to do what they do across the board if they're going to work in any of the motherboards that we currently use. Also on the right, our step, our direct, and our enable pins have to be the same. Now note, this is only true if it's from a manufacturer like Vodorat that's trying to make these compatible or backwards compatible with any of the boards that use the traditional Stepstick format. Companies are free to break any of these pins out to any of the various positions that they want, so just because you see a silent Stepstick driver that has a particular Trinamic chip on it, like a TMC 2208 or something like that, that doesn't mean it's going to work in your particular board. Make sure you check with the manufacturer, because it's quite possible that they used a unique footprint with unique pin designations that worked for the particular options that they wanted to use on their boards. Therefore, their board may only be compatible with their particular Trinamic drivers, unless you want to go through modifications. In which case, you just kind of have to pray to God that they properly documented their weird proprietary footprint, or that they opened up the source so you can figure what it is for yourself. Because otherwise somebody might buy this not knowing that and end up plugging the wrong drivers in, or the drivers in the wrong way, or with the wrong settings, and end up either frying their drivers or frying the microcontroller on the board. In which case you get a lot of angry people on the internet who will A, tell everyone not to buy the board, or B, tell everyone to avoid that brand of board altogether.
I heard
a new board is not selling well.
May I ask why?
Yeah, well.
The jumpers and driver support is weird.
And,
reviewers won't touch it without GPL compliance. Oh. Anyway, rants aside, the thing that differs between the silent Stepstick format and the Stepstick format is essentially these middle pins on the right side designated by the purple arc. Basically, those are dual mode pins, and depending on whether you're setting them in legacy/standalone mode or in smart control mode, they have different functions. So typically, unless you have a motherboard that specifically routes traces from those pins for one mode or the other, if you're going to be using these in smart control in a board that was designed for the Pololu step sticks, they'll take those pins and solder them up because they don't have any use on the board otherwise. And then those will be attached to specific IP pins with the functions that you need to drive those particular chips, like SPI or serial UART, using jumpers. Not the little jumpers we're talking about, like these big old long DuPont jumpers. A lot of people like me won't even bother soldering jumpers onto the unused header breakouts at all, because why bother? So for example, this TMC 2208 driver, I only have the UART pin soldered, and I have it soldered facing up because that's the only one I'm interested in for smart control mode. And that pin just takes the place of these two pins right here, which are not used in Trinamic as they are on the Allegro drivers. On the Allegro drivers, those are the sleep and the reset pins. And then sometimes the confusion comes in because they'll see different configurations with Trinamic silent step sticks, like with the TMC 2130. SPI uses a lot more jumpers than your serial does. It uses 4 instead of 1, so you'll see those 4 pins soldered up, as well as pins that are unique to the Trinamic drivers, like the diagnostic pin. So that's just to say that in smart control mode, those MS1 through MS3 pins that are traditionally used for your board jumpers aren't used at all. You don't need them at all. So you can just leave the jumpers off the board and you're fine. And if you soldered your header facing up with nothing on the down connecting it to the motherboard, you could leave your jumper pins off or on or whatever you want. It doesn't matter because they're not cooked up to anything. But in standalone, aka legacy mode, those jumpers serve slightly different functions than they do with the traditional Allegro Stepstick format. And mostly the confusion comes down to jumper number 3. The bottom line is you don't need it. Take it off, remove jumper number 3, throw it over your shoulder and never think about it again. unless the manufacturer of your particular silent step stick board did something special with it. In the case of like the TMC 2130s and the TMC 2208s and the TMC 2100s, that jumper number 3 doesn't do anything as far as the microsteps. Now, of course, that does change, and this is subject to change, so make sure you check. Because newer chips like the 2209s, they use that pin, not for microsteps, but we'll get to that. But for the original couple silent step stick drivers like the 2100s, let me show you what that pin actually does. On the TMC 2100, it sets the mode of current setting. And if we look further into the TMC 2100 documents, at least on the Vaterot boards in this particular version, you can see that they didn't even bother on the breakout board connecting that header at all, because configuring that pin is an optional feature. But it's very possible that other manufacturers did connect that pin or reuse it for other things, so make sure to check those data sheets. But if you want to be safe, leave it off. Now that only applies to the Vaterot designed TMC 2100 driver board. Since that was essentially just a wasted pin, in other drivers it's been reused for other features. One example would be the more recently released TMC 2209 drivers, which use that configuration 3 pin to select either stealth chop or spread cycle mode. And that was done to reuse that essentially unused pin in order to give you more options in terms of what modes you can and can't use, since the 2200 series as opposed to the 2100 series is not a tri-state pin, as in it'll only take a high or a low, it won't take float. So now let's talk about the second point of confusion, which is how that works with your particular board. And we'll go back to the TMC 2100s for this example because, like I said, those are tri-state jumpers. So it'll let me illustrate the range of possibilities a little bit better. So remember, like I said, our Allegro chips, they had the internal pull-down resistor so that they could only be either high or low. Well, the 2100s and consequently the 2130s, as we said, have 3 possible states. So if I color code those, it'll show you a little bit easier how those various combinations of state can get you a wider selection of modes with only the 2 jumpers, configuration 1 and configuration 2, because configuration 3, as we said, that jumper's left off. That means that which of these modes you can access is 100% dependent on your board, and we will use as an example our ramps board that we've been using all along. So as a refresher, MS1, aka the first jumper, is pulled down to ground naturally, or you can apply the jumper to the header and then it'll pull it up to our logic voltage. Whereas jumper 2, which is the only other jumper we can use to configure microstepping on these chips, can either be in floating condition or pulled up to our logic voltage, which means that we are somewhat limited to the number of combinations we can use. And that's led a lot of people to do various modifications to these boards so that they can access the different modes. So rather than rifling through the internet to try to find somebody who has hopefully put out a guide on how to use the particular mode you're looking for on the particular board you're looking for, all you have to do is figure out if your board can set the MS1 and the MS2 jumpers to either your logic true, your logic false, or your logic float. Then look at the data either from Trinamic's data sheets or on the Vaterot Silent Stepstick GitHub to see how you can set the jumpers on your board to achieve the mode that you're looking for. Bearing in mind that those jumpers do different things depending on which chip family you're talking about, so make sure that you're looking at the right documents for the right chip. Because with some of the families of drivers, it's very possible that the mode you're looking for isn't available in standalone and you're going to have to use smart control over UART or SPI. As an example, this is our Trinamic TMC 2208 silent step sticks, and the options are either 2, 4, 8, or 16 steps. All of them have interpolation on, and all of them are in stealth chop. If you want to turn the interpolation off or access other microstepping modes or move to spread cycle as opposed to stealth chop, you will have to use your UART interface. Now, I get a lot of questions, people like, I don't understand all these jumpers. What happens if I just leave them all off? Well, leaving them all off is not opting out of the whole jumper situation. Leaving them all off is just setting them into whatever mode corresponds to that particular pattern of jumper settings as it relates to the logic table for the chip. And as I've said, that varies wildly depending on your board and the manufacturer of your particular drivers, because they can set them to whatever mode they want. And that's consequently why it's very difficult to answer those questions, particularly if they didn't release the source for those drivers in that board. And whether you bought a version of those drivers that's either set up for standalone or set up for smart control or set up in, we don't really know because we didn't understand, we just kind of made a clone and stuck it out there. For example, here's a TMC 2208 that's pre-configured for standalone mode. If you wanted to do UART mode, you would have to make some modifications of tiny little resistor jumpers on the board, and you would have to modify these pins. But in its default state, technically these two pins should not be connected, as designated by NC or no connection, in which case you can just plug it into your board and not have to worry about them at all. And whether or not configuration 3 or the third jumper pin is hooked up to anything and what that anything actually does, well, that depends totally on what the board manufacturer decided to do, so hopefully they included some diagrams. Because that brings us to another use of the word jumper, which is the tiny jumpers that are actually on your Stepstick board. One of the uses of those jumpers is to either connect or disconnect certain functions on the IC to certain pins that are broken out to be used on your printer motherboard. For example, the UART pin on your TMC 2208s. If we move from that diagram into the physical world, you can see that there's a little blob of solder across two of these pads right here, which allows you to take the PDN UART function on your IC and connect it to one of the two pins on your breakout board, so that then you can hook that up with a jumper to use smart control over UART. If you buy these drivers from either Vaterot or DigiKey and they come in their raw state without the headers soldered on and that type of thing, typically they'll come in standalone mode, which means they don't connect that UART pin to anything. So you have to put a blob of solder across one of those two pads, and you can choose either one pin or the other to break your UART out to. Whereas if you buy one that's pre-configured for smart control, then that's going to depend on the manufacturers and which pin they chose to break it out to. So for example, this TMC 2208 that's set up for smart control, they decided to hook the UART up to the top pin and then leave this bottom pin not connected to anything. And that has the additional benefit of, if somebody decides to leave that MS3 jumper on, it doesn't do anything because that pin's not hooked up to anything. And again, a lot of these options are left up to the manufacturer of the boards and how they decided to use the various features that are available on these chips. Because if you read through the datasheets, there are other functions available for those pins as well, depending on what they've selected. So you can use that PDN UART pin in standalone mode for current power down, as in how the motor reacts in standstill mode, whether it lowers the current or disables that function altogether. Or they can use one-time programming mode to burn a particular configuration onto the chip for standalone mode, in which case that's the only mode that that stepper will ever run in. And in addition to using those small onboard jumpers to choose whether or not to break out certain functions to pins, there are functions on the board itself that are not broken out to pins that can be selected by these small onboard jumpers. And that's not usually something that the user has to concern themselves with, but they are configurable options. So if we look at the design files for the Vaterot boards, we can see that those jumpers that I pointed to in the previous picture correspond to different configuration settings, namely in this case, various options for the chopper, as in the T off or off time for spread cycle mode, and the hysteresis and blanking time for both the spread cycle and the self chop mode, which can be used to tune the driver for particular motors at particular settings, like the noise, the heat, the whine, etc. So whether or not they set those or just leave them blank is going to put the chopper in a particular mode, which may or may not work with the motors that you're hooking up off it and the operating point that you're running these. So while that is stuff that shouldn't have to be configurable by the user, In a perfect world, you would want to tweak those so that you don't have your chopper, say, running at a lower frequency than it should, so you get whine, or running your motors hotter than they have to, and then you get overheating issues with your drivers. And then there are other features of various chips they may or may not have hooked up. For example, these two pins on the Trinamic drivers, which typically aren't used for anything, and you'll see this funny little open source symbol on top of it. If you look at this driver that I got from Vatarad, circled in purple, you can see that there's nothing jumping across those two pads on the board, which means that pin directly above it isn't hooked up to anything, and we know that because we can check their design documents. That's the clock pin that manufacturers of motherboards can use for something, but typically it's not. Because moving back to our Allegro drivers and our ramps board, the ramps bridges the sleep and the reset pins together because they were for the Allegro drivers. Whereas on the TMC 2208, you would just be bridging the clock pin to the PDN UART pin, and I have no freaking idea what that would do. Or it's very possible that the manufacturer just homebrewed their own particular combination of pins and features that they map from the IC to their particular motherboards, which is very possible if they made a set of drivers and a board that's specific to those drivers, as in the ramps 1.6 Plus and the particular TMC 2130s that go along with it. Because that board was basically designed as a ramps that used their, kind of easy, no-brainer modules that fit into it, so you wouldn't have to worry about running a bunch of jumpers for SPI. They already ran that on the traces of the board. Unfortunately, they didn't release the source files for that, so I can't be of too much help there. Presumably, you can always just take your chip, solder the headers facing up so that's not connecting with any of the connections on the board, and then run jumpers yourself. Or if you're running in standalone mode, work through their kind of vague instructions on how you would hook up the MS1 and the MS2 jumpers along with the other ones for various chips, and then not solder on those particular sleep and reset pins, since those are mapped to particular functions for their drivers that are meant to go with the board. But I can't confirm or deny any of that without the proper source files or a lot of destructive reverse engineering. So, to sum this whole thing up, the main points you have to remember are that the jumpers just set a voltage that indicates a particular mode to the IC that's on your Stepstick breakout board. Also, all Stepstick boards and all motherboards are different, and it's going to depend on what options the particular manufacturer or designer selected for those particular boards. And the options for all your drivers are going to be different, so you can't just say, I need help with my TMC 2208s. You have to say, I need help with my TMC 2208s from this particular manufacturer that were sold as this particular mode, as in smart control or standalone mode. So if you're a beginner and you've been frustrated with trying to get information with your particular problems, that might be one of the big things. Make sure to give all of that information if you go to like Reddit or some other forum and try to ask for help, because otherwise you're just saying the equivalent of like, what tires should I get for my car, with no additional information. Obviously, that's going to vary drastically. But hopefully this video has given you enough information that you can figure that out yourself just by taking your drivers, looking through the data sheets and the directions that they have available for the particular manufacturer of your board, and figuring out what your options are. If you have any questions, feel free to leave them in the video comments below. I try to get to as many as possible, but again, if they're either vaguely formed or I get super swamped, I do what I can. Also, while you're down there, please check out my support links and consider subscribing to the channel. Thanks for sitting through it this far, and until the next video, get out there and make something awesome.